Hello, we are here for one more lesson of the T-FLEX analysis training course, and the topic for today will be some references for statics analysis that we've been talking about in these previous lessons. I will make a very simple model, a cube, just to show you one detail, and for that I need to create a study. I need to create one mesh. It doesn't matter the size of the mesh, it's simply to create a mesh. And when we go to material, we have a couple of properties of the material, and this is a lesson simply to explain a couple of definitions which you can find much more in detail in our theoretical course. And if you go and search a little over the internet, you'll have a lot of description examples, just to focus a little about this, because these are important topics. Just to tell you that, as you might imagine from everything we talked until now, a proper assignment of the material properties that we use to be a base for these calculations, it's super important, and not only for having correct results, but to simulate properly what we want in terms of real life or practice. And we have a couple of main properties which are very important, and each user should be aware and should know very well what they mean and what they are. Even that these properties, if you consult technical literature, you have tables and lots of information about the correct values, but it is important to understand. And we have 3 or 4 important topics. One of these topics is something called the elastic modules of the material, which is something that we have here under the properties of a material. This elastic module is a ratio of stress with respect to relative strain. We have some details more about this definition, but basically it's enough to understand what it is. Okay. Then we have another thing called the elastic limit, and the elastic limit, if you search, we don't have that graphic here, but in our theoretical course we have an image of the graphic, because we have a diagram that is very well known in terms of mechanics, which is the stress diagram for plastic materials. And we have a couple of points, very important points in that graphic, and one of them is the elastic limit, which is the point until when, if the material suffers an extension or a stress, better saying, it will recover, because it's on one area that we define with elastic elongation, or it's still on elastic area. That means that it recovers the shape after the stress is 0 again. After that point, we go into another area that is called the plastic area. Then we have another point called the yield limit, that you can find also in this diagram. And this yield limit means that further elongation of this part, or of the thing that you are testing, occurs practically with no increase of the load. So it will pass to an area that will no longer recover the shape, and it will start to stretch with almost zero force, okay? And this phenomenon is called the plastic flow. And if you see on the diagram, it is basically a more or less horizontal line, because it means that with a very low force or load, it will start to elongate. Another important point, it's the ultimate strength, or what we call the rheological resistance, and is the stress, this point, which upon exceeding the material will rupture. So it will, what we call in terms of normal words, it will break, it will separate itself. And it's another topic that we can find on this graphic. We have also another one which is important, and I will finish with this one, that it's also in these properties. Poisson Ratio characterize the transverse strain developing in a stretching part in the elastic zone. So there are a couple of definitions also under there, and we have tables again with all those coefficients. But it is interesting to know what each one of these properties it is. If you see in this table, we have a couple of them more. The thermal expansion, which is, and the thermal conductivity, very important for thermal studies, and also the specific heat. These ones, you have them tensile and compressive strengths are important, and we've seen already some examples, or at least one lesson, if I remember, where these were important values, because they give you also an idea to interpret the results you get in some studies. The density, it's important also because of weight and other factors, but it's one of the things that we need to calculate weight of parts and that kind of stuff. I hope that these brief notions were important. You can consult more things about it in our theoretical course, or if you look a little in technical literature, you'll find some details about all of this. But any additional help that you may need about this, you know that you can consult us, and we will give you all the necessary supports or clarifications that you might need.